In this session, we're going to talk about sketching quadratics or quadratic functions. Now, what is a quadratic function? You know that a quadratic function is just a function that is in the form of f of x is equals to ax squared plus bx plus c. Okay, this is a quadratic function. Now, the highest power of a quadratic function, or the highest power of x, is 2. If I say f of x is equals to x squared, this is still a quadratic function. Okay, now how do we sketch quadratic functions? Let's say you're given to find, f of x is equals to x squared. How do you graph f of x is equals to x squared? Let's say this is our graph. Okay, so now how are you going to graph this one? So you realize that your graph x has a positive number, so you are going to the the positive values of x. Okay, so for your quadratic, it will just be you are moving from the and you pass through this point. If you're going to start at 0, 0 and you pass like that, so this would be the graph of x squared. Okay, then what if you're asked to find f of x? Let's say this x squared, we have a negative in front like that. So how are you now going to graph this type of a quadratic? Let's say this is our y-axis, this is our x-axis. Okay, so now how are you now going to draw that? Okay, so you realize that since because the coefficient of x there, it is negative, it's just showing you that the graph is going in the negative direction. So in this case, our graph will to go like that, to pass like that, and to go like that. Okay, so in other ways, it will just be like a reflected graph of the x squared. Now, there are rules that you are supposed to understand for you to understand what. You're able to see that one is pointing upwards, the other one is pointing downwards. So rule number one that you should remember is that your a in this case is the coefficient of your x squared. Okay, when your a is less than 0, it means you have what we call a minimum or a maximum actually. So a maximum, a graph that looks like that. Okay, like this one that we have. When you have a negative, okay, a is less than 0. Okay, you're looking at numbers that are less than 0. Okay, then when you have a is greater than 0, okay, you're looking at positive numbers now. So you have a minimum. Okay, a minimum. Okay, so this one you're saying this one is a maximum, this one you're saying is a minimum, like that. Okay, so those are the kind of graphs that you're going to have. Okay, now let's solve more graphs. What if you're asked to find you're asked to graph f of x is equals to, let's say, x squared. Now let's put a constant. Let's say you put a constant 2 like that. Okay, so how is the graph going to be like? So your graph in this case, let's say we draw it let's say here. Okay, let's say this is our y-axis, this is our x-axis. Okay, so now how do you draw that? You're able to see that the value of x in this case, x is positive, so you are going to the positive values of x. Okay, but now you have a shift in the y direction, a shift of 2 units. So in this case, your graph is going to start at y is equals to 2. Okay, or at 2. So in this case, let's say this is our 2. Okay, so our graph in this case, since we're saying it's supposed to go up, so it will come down and pass through this point and go like that. Okay, so this is the graph of x squared plus 2. Okay, now let's say if you are what if they give you f of x is equals to, let's say, negative x squared, let's say minus 4. Okay, so how are we going to solve that one? Let's say this is Cartesian plane or x or y plane. Let's say this is our y axis, this is our x axis. Okay, now you are able to see that the graph has been shifted direction 4 units, okay, by negative 4. Okay, so negative 4 in this case would be, let's say your negative 4 in this case, let's say this is negative 4. Okay, but now the coefficient of x in this case is negative, so it means you're going to the negative values of x. Okay, or we said when your a, in this case, when your a is less than 0, when your a is less than 0, when your a is less than 0, you have a minimum. Okay, a minimum, or a maximum. Actually, you have a maximum. Okay, so a maximum in this case, so your graph will just pass there. So in this case you have a maximum, so it will pass through this point where it has shifted, and it will go in that direction. Okay, so that's one of the consideration that you might want to take. Then let's say you're asked to graph, let's say you're asked to graph x. Let's say f of x is equals to x squared minus, let's say, minus 3. How are we going to graph that one? Okay, if we say this is our x or y plane, okay, this is our x, this is our y, this is our x. Okay, now how now going to graph that one? So you're able to see that the graph has been shifted by negative 3 in the y axis. Okay, so let's put our negative 3, probably let's say put it here. Okay, now so if our graph is going to turn from here, we have to also look the coefficient of x. The coefficient of x in this case is positive, so we're going to the positive values of x, so it means we're going in this direction. Okay, so your graph will come, it will pass through this point, and it will go like that. Now you realize that your graph is cutting the x-axis at 2 points. Okay, in the axis at this point, and it's cutting the x-axis at that point. So you have to find the x-intercepts, and at the x-intercept y is equals to 0. So you have y is equals to x squared minus 3. So we are saying y is equals to 0. So 0 is equals to x squared minus 3. When you take the 3 on the other side, you have 3 is equals to x squared. You take the square root on both sides. So in this case you have, you know, the root and the square will cancel. Just have x is equals to positive or minus the square root of 3. Okay, so this will be, you know, negative root 3. This will be positive root 3. That's where it's cutting the graph like that. Okay, now let's solve a question. Let you ask to find f of x. Let's say f of x is equals to, let's say, x plus 2, but now the square is outside. So how are we going to solve this one? So now you're able to see that the shift is in the x direction. Okay, shift is in the direction. So how would your graph look like? Say this is your y-axis, this is your x-axis. Okay, then how will our graph? Now you're able to see that we've said so you have to equate this so that to 0, so that you see where x is shifting. So x plus 2, this will be equals to 0, so x is equals to negative 2. This is our shift in the x direction, so it has shifted to negative. Let's say our negative 2 is here, So that's where our graph is going to start. Then it means now we look at the coefficient of x. In this case, it's a positive number, it's just positive 1. So we are going to the positive values of x. Okay, so now how is it going to be? You come from there, you pass through this point, okay, and you're going to go in this direction, and you're going like that. But now you realize that you're cutting the y-axis at this point. Now at that point, you know that on the y-axis x is equals to 0. So you get your equation to find, you know, the y-intercept at that point. Okay, so you are saying f of 0 will just be equals to wherever there is you know, x will be placing by 0, okay, squared like that. So f of 0 in this case will just be equals to 0 plus 2, that is just 2 squared, that is a 4. So it's cutting the y-axis at, you know, 4. That point is 0, 4. So that's how we find that one. What about if you're asked to find they say f of x is equals to negative, let's say x plus 2, let's also square this one. Okay, so what are you going to have? Now you're able to see that even in this case, your graph, your x axis or your x has been shifted to 2 units. Okay, so what are we? So we said you equate this one that is in the, you know, in the root to be equals to, let's say 0. So x plus 2 is equals to 0. So x is equals to a negative 2. So it has been shifted by to negative 2 like that in the x direction. Now the coefficient of x in this case is, you know, positive. Okay, but now the coefficient of the whole function, you know, there's a negative there. So what does that mean? It just tells you that the graph in this case will be going downwards. Okay, the function will be going downwards. So how is it going to be? So it will go there, pass like that, okay, and it will go like that. But now you're able to see that it's cutting the y-axis at that point. So you have to find, you know, the point at that point. So you know that at the y-intercept x is equals to 0. So just go, f of 0 is just equals to, you replace in the equation, so you have minus 0 plus 2 squared. Okay, what are you going to have? You know, you've got 0 plus 2, that is just a 2 squared, minus 2 squared, that is just a 4. Then you have a minus outside, so it means this point will be negative 4. That will be our y-intercept. Okay, let's say also ask to graph f of x is equals to x minus 1, this is squared, plus 2. Okay, we're able to see that it has, our graph has shifted in the x direction. It has also shifted in the y direction. So how are we going to you know, show that? This is our graph, this is our y-axis, this is our x-axis, like that. Okay, so now how are we now going to graph this one? We are saying it in the y direction it has been shifted by 2 units. So let's say this, let's say our 2 is here. Let's say this is our 2. Then in the x direction, you are equating what is in the brackets to be equals to 0. So x minus 1 is equals to 0, x is equals to 1. This is our shift in the x direction. So it means x, let's say our 1 is just there like that. So the point is here, 2, you know, 1, 2. So now that 1, 2, that's where our graph is going to start. But now you look at the coefficient of the function and the coefficient of you know, the squared like that. So you're able to see that both of them are positive. So we are going in the positive, you know, x, the positive values of, you know, of x. So to go, it will pass through that point. because that's where it's supposed to start, and it's going like that. So now you realize that it is going to cut the y-axis at that point. Okay, so you have to find the point there. So what are you going to do? On the y-axis, x is equals to 0, so you're going to say f of 0 is equals to 0 minus, this is 1 squared plus 2. Okay, 0 minus 1, that is just a negative 1. Okay, so negative 1 squared, that is just a positive. So 1 plus 2, 1 plus 2, that is just a 3. So this point here will be a 3. That is the y-intercept at that point. Let's also to graph another one. Let's say you're asked to find let's say f of x is equals to, let's say, minus x minus 3, this is squared plus 2. Okay, now how are you this one? Okay, let's draw our graph in advance. Let's say this is our y-axis, this is our x-axis. Okay, so now how is our graph? We're able to see that x has a shift and the y also has a shift. So to find the x shift, you equate this to be equals to 0. So we have x minus 3 is equals to 0. So x is equals to 3. So it has been shifted 3 units in the x direction. So let's say 3 is here. Okay, so it means then our y, it has been shifted 2 units in the y direction. So we say, let's say our 2 is here. So our graph probably is going to start from there, if that is the point. Then either go this way or it can pass this way. So now how is it going to be? So for us to be sure, we have to find the y and the x intercepts at that point. So at the y-intercept, you know that x is equals to 0. So you're going to say f of 0 is equals to, let's say it's negative. Wherever there's x, we're putting 0. So 0 minus 3 squared plus 2. Okay, so what are we going to have? Minus, negative 3 squared. 0 minus 3 is just minus 3. Minus 3 squared, that is just giving us a 9. Okay, a 9 plus 2. Negative 9 plus 2, that is a negative 7. Okay, so negative 7, let's say our negative 7 is here. Okay, it's this point. So this is negative 7. So that's where it's going to cut the y-axis. Okay, so now let's run. So it means that our graph is going to go okay. Now you're able to also cut in the x-axis at 2 points. Okay, so we have to find the x-intercepts at those points. Okay, x-intercepts, y is equals to 0. So 0 is equals to negative, you have x, this is negative x minus 3 squared plus a 2. Okay, so how are we going to solve this one? Okay, let's take the negative, the one with the square to the other side. So you just have x minus 3, this is squared, is equals to, you remain with a 2 on the other side. So what are you going to do? You're going to square root both sides, so this side and this side. The square and the root will cancel, so you have x minus 3 is equals to positive or minus the square root of 2. So your x in this case will just be, when you take the 3 to the other side, you have positive or minus the square root of 2. You have a plus 3 like that. Okay, so those are our points. So provided you're not able to solve this one in the exam, okay, then if you're allowed to use a calculator, you can use the calculator. If you say 3 plus the square root of 2 and 3 minus the square root of 2, what are you going to have? For this one, on my calculator, I'm getting 4.4. For this other one, on my calculator, I'm getting 1.5. Okay, So now we're saying this is 1.5 and this is 4.5. So this would be our 1.5 and this would be our 4.4 actually, 4.4 like that. So those would be our points. So this point that we've just found, so now you're able to see that the turning point of a graph just shows you the shift in the x direction and the shift in the y direction. Okay, that will be your turning point. Okay, now let's solve some quadratics. Okay, let's say you're given to find f of x is equals to, let's say, x squared plus 2x, let's say, plus 3. Okay, so what are you going to do? We're saying completing the square, at least express this your expression in standard form. The standard form, that it is just f of x is equals to, you have to make sure that it's in this form: a x plus p, this should be squared, plus q. So this is your standard form. Okay, standard form in this case. Okay, your p in this case, x coordinate at the turning point, then your q, this is the y coordinate at the turning point. In that regard, you're just saying this is just the shift in the x and the shift in the y. So now how do we solve using the completing the square? So we're going to say f of x is equals to, okay, so you're going to say x squared, you have the coefficient of x, okay, of x, in this case your 2, when you have your 2, it will just be half, right? It will just be 1, right? And you square that, okay, and you minus again 1, the square root of that, okay, plus 3. In case you're finding it hard to understand completing the square, okay, there's a video that we've done there, you can still access that. Okay, so what do we going to have? We're going to ignore the 2x and we're going to put those ones, the square, in one bracket. So what we'll have x plus 1, this will be in their own bracket. Now we've got minus, we've got 1 squared. Okay, 1 squared is just a 1 plus 3 there. So now how are we going to solve? So f of x in this case will just be equals to x plus 1 squared negative 1 plus 3. That will just give us a positive, it will give us a positive 2. Okay, now you're able to see that this has been expressed in that form. Okay, it has been expressed in that form. So now how do you now graph the function? So we've been given everything, so it will be very easy for us to graph this function. So let's say this is our y-axis, this is our x-axis. So what are we going to have? So you're able to see that this that is in the bracket, for you to find the x shift, you're going to equate it to 0 or line of symmetry. That will just give us the line of symmetry or the middle of the graph. Okay, when you cut the graph into two parts. So what are we going to have? So we are going to say, we are saying x plus 1 is equals to 0. So x in this case is equals to negative 1. So this is the shift in the x direction. Okay, so let's just put that point. This is, let's say, negative 1 is here. Okay, then let's also find the shift in the y. The shift in the y, you're able to see that it's only a positive 2 there. So what are we going to have? So I say a 2 for y will just be somewhere there. Okay, so let's say our point is negative 1 comma 2 is here. Now you look at the function. The coefficient is positive for the whole function. Even the coefficient of x is also positive. So the values of that are positive and the function is going in the upward direction. That's where we find the positive values. So it will come from down, then it will pass through the turning point, then it will go like that. Okay, now if this is our function, it is cutting the y-axis at that point. So if it is cutting the y-axis at that point, we have to find that point. Okay, So what is that point? So you know that at the y-axis, or on the y-axis, x is equals to 0. Okay, so now what are we going to have? To find that, we're just going to, equate. We're saying x is equals to 0, so f of 0 will just be equals to 0 squared plus 2, 0 plus 3. So 0 squared, that is 0, 2 multiplied by 0, that is 0. 0 plus 3, just 3. Okay, so it means this point where it's cutting the y-axis will just be 3, like that. Okay, so this is how you graph this function. Let's solve another one. Okay, let's solve the last one. What if you're given to sketch f of x is equals to a negative 2x squared plus 6x plus, let's say, 1. Okay, so in this case you are going to factor out a, but our a in this case is what? Negative 2. Okay, negative 2. To make it easier and faster, let me choose this part. Okay, let me choose this part and we'll go like that. So the 1 will leave it on the other side. So what are we going to have? If we factor out negative 2 there, we are going to have 2 outside. Okay, this you have x squared minus 3x. Okay, this is plus 1 outside there. Okay, so you know that it should be in that form: a x plus p, this is squared plus q. That's why we're factoring out our negative 2. So what now do we have? Okay, so in this case we're going to find the half of the coefficient of x. Okay, and we're going to square that. So negative 2, we're going to have, let's say we do that, we have x squared minus, so your 3x, let's write our 3x, the half of 3x, it will just be the half of negative 3x, or negative 3 multiplied by half. That will just give us negative 3 over 2. Okay, so you have that. So we're saying plus, so you have negative 3 over 2. Now what are you going to do to this one? You're going to square it and you're going to minus at the same time. Okay, so you have 3 over 2 squared plus, okay, the 1 actually is outside, so we'll just add it outside like that. Okay, so we have a negative 2. Then what do? We ignore this the one that we halved. Then the ones with the squares, we put them together. So we've got x minus 3 over 2. This is squared. When you do that, you will have, when you simplify this one, negative 3 over 2 squared. What are we going to have? You just have, you have a minus there. 3 squared, that is just a 9. 2 squared, that is just a 4. Okay, this whole expression. Then there's a plus 1. Don't forget your plus 1 throughout. So we have a negative 2. Okay, negative 2. Let's distribute the negative 2. Okay, if we distribute the negative 2, the big bracket will be out, so you have negative 2. So now we just have x minus 3 over 2. This is squared. Okay, we've got the minus, but now because we are distributing 2 on the other side, so it will be plus 9 over the 2 divided with the 4 here, so you just have a 2 there. Okay, you just have a 2 there like that. Okay, then don't forget your 1. Your 1 again will just come now. You will just have a 1 there. Okay, so now what are we now going to have after we've distributed 2 like that? We can also simplify 9 over 2 plus 1. Okay, to make our, we're going to do, 1 is just the same as 2 over 2, right? It's just the same, so we can also just write that on 1 just to make it easier to solve the other side. So what are we going to have if we do that? So you have negative 2 x minus 3 over 2. This is squared, then plus, you just have a 2 as a common denominator. 9 plus 4, that is like 11. Okay, 11. So this is our fully form. So now what are we going to have? So you're able to see that your turning point, because your turning point should be negative p comma q. Okay, our p in this case is this expression. It's negative 3 over 2. Negative 3 over 2, but because it's negative, so in this case it will be positive, right? 3 over 2, comma, our q in this case, you're just going to get the constant. In this case it's 11 over 2, so it will just be 11 over 2, like that. Okay, or if you want, you can divide that to give you that. Okay, so now that we found the turning point, is our graph going to look like? Okay, so you can also find the x and the y intercepts. Okay, the x and the y intercepts. Okay, so that on the x, okay, so we can solve. Okay, I think we can solve even from here. Let's draw a diagram. We can just draw it from here. So let's see our graph. If we're going to graph, let's say our y-axis, this is our x-axis. Okay, so now to find our x-intercepts, where it's going to cut the x-axis, y is equals to 0, right? So it'll be 0 is equals to, okay, the fully expressed form that we had, it was negative 2, which was outside, when we had x minus 3 over 2. Okay, this is squared plus 11 over 4. That was the expression that we had, and x is equals to 0, like that. So what are you now going to have? So you're going to take this expression to the other side so that it becomes a positive. Okay, so in this case you have 2 x minus 3 over 2. This is squared. You have on this side you've got 11 over 2. Okay, just to remove the fractions, let's multiply the whole expression by, let's say, 1 over 2. So your 2 and your 2 cancel, right? So this side you have x minus 3 over 2. This is squared is equals to your 2 multiplied by your 2, it will just give us a 4. So 11 over 4. To remove the square root, we are going to square root on both sides. Okay, so we'll have x minus 3 over 2 is equals to the square root of 11 over the square root of 4, that is, it is a 2. Please don't put the square root like throughout like that, because it's not the same as what I've written. Okay, don't make that mistake. So now what are we now going to have? We're going to take we're going to say x is equals to the square root of 11 over 2. When then the negative 3 over 2 goes the other side, changes the sign, so it will be positive 3 over 2. Okay, so since all of them have got a 2, you can factor out the 2 if you want. Okay, so in this case, will just be x is equals to the square root of 11, okay, you can even say the square root of 11, because we've got positive or minus, so the square root of let's say, because it's positive or minus, square root of 11 there will just be positive or minus the square root of 11. So let's say you have 3, x will just be equals to 3 positive or minus the square root of 11, because 2 is common as a denominator, it will be like that. So those are the two values of x that we have. So you can divide those ones. If you, when you solve that, what are we going to have? Okay, what are we going to have when you solve that? So we are saying you have x is equals to 3, 1 is plus or minus, okay, plus over 2, then the other one is 3 minus the square root of 11 over 2. Okay, on the top part, if I do on my calculator, I'm finding 3.2. Then on the other part I'm finding okay, on the other part I'm finding negative 0.2. So these will be our values. Let's say negative 0.2 is there, 3.2 is there. So these are our x intercepts. Then at the y-intercept, you're going to equate the whole, the whole expression to be equals to 0. Okay, so if you express the whole expression to be 0, so this will be 0, this will be 0, and you only remain with a 1. So let's say it's cutting the y-axis here. This is 1 there. Okay, now how do you find the turning point? We've already found the turning point, 3 over 2 comma 3 over 2 comma 11 over 2. Okay, now let's draw nicely. We have everything that we needed to find. So our graph in this case, it will be, we are saying the turning point is at 3 over 2. Okay, so let me put this this one here. Let me remove this a bit. So what are we going to have? Let me say that one is a bit this side. Let's say it is 3.2 is here. Then we've got the turning point 3 over 2, okay, somewhere here. Then we said this 3 over 2 comma, the square root of, we've got 11 over 2. Now 11 over 2 is just the same as 5.5. So our 5.5 will just be, let's say, here. So our point will be, our turning point will be somewhere there like that. Now if we were to join these points, you move all the way from here, you pass through your x-intercepts, you pass through the y-intercept, you pass through your turning point like that. Okay, then you go until you pass through this point like that. So this will be the graph of that function. Okay, thank you. See you in the next session.